Section 11.6 is about different types of crystals. We are going to be talking about 4 different types of crystals, and you need to be able to identify different types of crystals based on the formula of the substance that's in the crystal, the molecule or the compound, and also its properties. So the first type of crystal that we're going to talk about is an ionic crystal. It's a crystal that's made up from an ionic compound. So examples of ionic crystals would be those made from sodium chloride or potassium bromide or any ionic compound that you can think of. One of the characteristics of an ionic crystal is that it's made up of different sized particles. And the different sized particles that I'm referring to are the cations and the anions. You learned last quarter that cations and anions are not the same size. The cations are much smaller. So in the sodium chloride crystal, you have small sodium ions and large chloride ions and 2 different sized particles, and that's a unique feature for an ionic crystal. Ionic crystals have high melting points, and they also have high lattice energies. And they are not good conductors as solids. They are good conductors, or they can be good conductors if you liquefy them, if you heat them up. And I'm not talking about dissolving them, which also makes them good conductors. If you dissolve them in aqueous solution, then they're good conductors of electricity. But if you liquefy them, you just take them and heat them up until they turn into a liquid. Liquid ionic substances are good conductors, but not when they are solids. The second type of crystal that we're going to talk about is a covalent crystal. And these are crystals that are made up of atoms that are covalently bonded to each other. So one example would be diamond, which is a network of carbon atoms that are covalently bonded to each other. The bonding in a covalent crystal extends 3-dimensionally. So not only do you have atoms bonding side to side, but they're bonding up and down and across, and you just get this humongous network of covalent bonds. Covalent crystals have high melting points. They are very hard. If you think of diamond as the example of a covalent crystal, it has a very high melting point. It's a very hard substance. It's not brittle. Ionic crystals are typically very brittle substances. And these also are not conductive at all. Next is molecular crystals. These are crystals that are made up of molecules. So one example would be ice, which is solid molecular water, or also frozen phenylsalicylate. Molecular crystals are networks of networks of molecules. They're held together by their intermolecular forces. They typically have low melting points, and you may think, well, ice has actually a pretty high melting point, and it does. But relative to the melting point of sodium chloride, these substances have much lower melting points. They're soft. As you know, it's pretty easy to smush ice, especially compared to how easy it is to smush diamond. And these also are not conductive. And last but not least, we have metallic crystals. For example, iron or sodium, metal, not ion, or any metal that you can find on the periodic table. Metallic crystals contain metal atoms. Not ions, held together by intermolecular forces. They are very conductive. And they are going to vary in terms of their melting point and hardness. So they'll have, some of them will have high melting points, some of them will have relatively low melting points, some of them are harder than others. For example, sodium metal you can cut with a butter knife. It's a little bit harder than butter, but not much. And iron, as you know, obviously you couldn't do that. So there's a variation in terms of their hardness. It's a characteristic of the different substances. So for this, that's all that we have in this section, just a bunch of definitions. For this section, your study question is, what are the 4 types of crystals? And how are they different? And you should take a look at problems. These problem numbers are the same for both the 10th and 11th edition. Take a look at problems 51, 52, 53, 54, and 55. 55 being one of the problems that you're assigned for your homework. The others are just practice. And these problems will give you a practice looking at formula and identifying what type of crystal it is, or looking at characteristics and identifying what type of crystal it is. So these are the types of questions you would expect to see on a test.